Hello everybody. Today we are going to talk about graphs of quadratic equations. Okay, so a quadratic equation is an equation of the form y equals ax squared plus bx plus c, where a is not equal to 0. Now here's the thing. If a was equal to 0, this would disappear. You just have bx plus c. That's a line, okay? Y would equal, basically you could say y would equal mx plus c plus b. That would just be a y slope-intercept form. Okay, so a can't be 0. It could be anything else. A quadratic equation has a graph with a U shape that is called a parabola. Okay, all quadratic equations are shaped like a parabola. It's just kind of a U. It's either up or down. If a is a positive number, if this number out here is positive, it's open upwards, so it's shaped like this. If it's negative, then the U shape is open down. Okay, so here we got a couple of examples. Okay, so this equation, y equals x squared. Okay, a is 1. Okay, so the graph is open upwards. Now, it's okay for b and c to be 0, just not a. So in this case, y equals x squared. A would be 1, b would be 0, and c would be 0. Okay, so this is open upwards because a is positive. Now over here, y equals negative 2x squared plus 4. A is negative 2, so it's open downwards. So right away you can look at the equation and tell whether it's open up or open down. Okay, the vertex is the highest point on the graph if it's open down, or is the lowest point on the graph if it's open up. So here we would have our parabolas open down. Here's the vertex, okay? Here it's open up. Here's the vertex. It's the lowest point. Now, the vertex is always located on the axis of symmetry, okay? These black lines on both of these are the axis of symmetry. In this case, it's at 2. X equals 2 is the axis of symmetry. In this case, x equals 0 is the axis of symmetry. Okay, so how do we graph a quadratic equation? We follow these 4 steps every time. Okay, so here's my graph. Y equals ax squared plus bx plus c. If a is positive, the parabolas open up. If a is negative, the parabolas open down. The axis of symmetry is the vertical line that's always located at x equals negative b over 2a. Okay, so what you do, let's go back here on this one. Well, okay, neither one of these has a b. We'll look at it in the next slide. We'll have a couple. Okay, so I use negative b over 2a is going to be my axis of symmetry, and then I take that number, whatever it is, and I plug it into the equation, and I find the y coordinate, and that gives me the vertex. Okay, so here we go. Find the axis of symmetry, use the axis of symmetry to find the vertex, graph 2 points to the right and 2 points to the left of the vertex. So that's what we're going to do every time we graph a quadratic equation. Okay, so we know that the axis of symmetry is always located, I'll just write this down here, the axis of symmetry is located at negative b over 2a. So one of the things that I like to do is I like to label my a, b, and c here. So a is going to be 1, because that's the coefficient of the x squared. B is going to be negative 2 right here, and c is going to be negative 3. So now I can calculate my axis of symmetry. It's going to be negative 2. Okay, it's negative b, and b is already negative, over 2 times a. So this is just going to be 2 over 2, which is 1. Okay, so my axis of symmetry is located at 1, and I always put that on my graph right away. Let's use this. Okay, so my axis of symmetry is at 1. I'm going to go ahead and put a nice line right there at 1. Okay, now what I'm going to do is I'm going to make a table next And in my table, the very first number I'm going to put in there is 1, because I'm going to find my vertex. So I take my equation, which is right here. Okay, so x is 1. That'd be 1 squared minus 2 times 1 minus 3. So that's going to be 1 minus 2 is negative 1, minus 3 is negative 4. This is my vertex right here. And I'm going to go ahead and put that on the graph. 1, negative 4. Now I know this is open up right here because the 1 is positive. So that's going to be the lowest point. That's going to be the minimum of my graph. Now, once you've got the vertex, I just need to pick 2 points to the right or the left. Okay? Now, here's the great part. I really only need to do 2 on one side because remember, this thing's symmetric. Anything on this side is going to be equal on this side. So I always like to use 0 if I can because it's super easy. If I plug 0 in here, I know that's 0 minus 3. That's negative 3. I can do that very quickly. So 0, negative 3 is on the graph. Now I did 1 point. I'm going to get another one for free because this is symmetric. So this point is also going to be on the graph. That's the point 2, negative 3. Okay. Now, another nice one to do would be to put 3 in here. Okay, if I put 3 in here, I'm going to get 9. 3 squared is 9. Minus 2 times 3 is going to be 6. Minus 3. So that's going to be 0. 3, 0 is going to be on the graph right here. Now, that's going to give me another point because it's symmetric. I'm 2 to the right here, so I go 2 to the left. That point is also going to be 0. Now, I can really draw my graph right now. I really only need to have 5 points, but I've got all this extra room up here. So I think I'm going to do 1 more point just to make this look really nice. Okay, so I always like to deal with positive numbers if I can. I'm going to go ahead and put 4 in here and see what I get out. I don't want to go too far because then I jump way up out of the graph. So 4 squared is going to be 16. Okay, minus 2 times 4, that's going to be minus 8, minus 3. So that's going to be 8, 5. Okay, so 4, 5 is going to be on the graph. 4, 1, 2, 3, 4, 5. And remember, this is symmetric, so I get another point for free. I'm over 1, 2, 3, 4. I'm going to go over, or I'm sorry, I'm over 1, 2, 3, so I'm going to go over 1, 2, 3. That's going to be on there too. And now I just sketch in the graph. So it's going to look something like this, and it's going to look something like this. And I'm done. I didn't do a very good job of sketching that. So I might want to kind of clean this up a little bit. I don't know, my graph's off a little bit. But that's okay. Now, the points that I always like to have on the graph, if I can, I like to have the y-intercept, okay, which is right here. And I like to have the x-intercepts, which are right here and right here. You can't always get those on your graph because sometimes if my graph's way over here, then my y-intercept might be way up here or way down here. But if I can get them, I'm going to put them on there. Okay? So that's the way I do it. I calculate the axis symmetry. I put that line on my graph, a dotted line. Okay? I use that number to calculate my vertex by plugging that into the equation. Boom, there's my vertex right there. I find at least 2 points to the left, and I use their mirror image on the right, and I graph at least 5 points. In this case, I did 7. Okay? So there we go. All right, here's the next one. Okay, so again, we're going to start out with negative b over 2a. So in this case, b is negative 1. That's going to be positive 1 over 2 times a is negative 1/2. Okay, so this becomes 1 over negative 1, which is negative 1. So I'm going to go ahead and I'm going to put my axis symmetry at negative 1 right there. Now I'm going to make my table. And I'm going to start out with 1. Or, I'm sorry, negative 1. Okay, so I plug this in here. Negative 1 squared is 1 times negative 1/2. That's going to be negative 1/2 minus negative 1. That's going to be plus 1 plus 4. So this is going to be 4.5. Okay, 4.5. Okay, so then on here, I'm going to go to 4.5. 1, 2, 3, 4.5, right there. There's my vertex. Now, I know this thing's going to be open down, so my graph should go this way. It should be a little wider than normal because they've got that half out there. Okay, I'm going to choose my 0 because that's really easy to calculate. It just makes all this 0 and gives me plus 4. Okay, so 0, 4. And I get another point for free. I'm going to get this point right here is also going to be 4. That's going to be negative 2. It's going to also be 4. Okay, now I'll pick another one. I'm going to go out here to 2 because I want to get out here a little bit wider. 2 is a nice number to use. So 2 squared would be 4, and negative 1/2, that would be negative 2. Okay, whoops, this should be down here. So negative 2 and then minus 2 plus 4. Hey, that's convenient. That's 0. That's a y-intercept or an x-intercept right there. I like that. Okay, now I'm also going to get 1, 2, 3. I'm going to go 1, 2, 3. I'm going to get a x-intercept right there. That's at negative 4, 0. Now I've got 5 points. I'm going to go ahead and just sketch my graph in now. It's going to look like this. And I'm done. Okay, pretty easy to graph a quadratic. Okay, so this is fun. Justin Herbert, former Oregon Duck, threw one of the longest touchdown passes of all time. The ball follows the path of y equals negative 0.0056 x squared plus 1.0333x plus 7. What is the maximum height of the ball and how far did he throw it? So basically what I want to find is I want to find the maximum height. I want to know that distance right there. And then I also want to know the distance that he threw it. So I'm going to want to know this distance right here. Okay. So I've also included the link here. You can go watch this throw. It's a very nice throw. It's very much worth watching. Okay. So how do I do this? Well, you get out your handy dandy TI-84 Plus C Silver Edition graphing calculator to start with. Okay. And I've got all the directions here for how you enter this thing. Okay. So here's what we're going to do. We're going to enter the equation and we're going to graph it. And then we're going to find this point first. That'll tell us how high the ball went. That's the maximum height of the ball, okay? So I press the y equals key right here, brings up this screen. I enter that equation right in here, okay? And then I hit the graph button. All right, now here's the thing. Depending on what window I have in here, I might not have a very good picture of the graph. It may not even show up. So once I've got a graph in there, I'm going to adjust my window so that I make sure the graph gets in the window. So here's the way you do that. You push your window key, okay, and it'll ask you the x minimum, okay. So you're going to put a number down here. Now he throws it from 0, but you don't want to put 0 in there because it cuts off this edge. Go a little bit further than that. I put negative 10 in, okay, and I put my x max to be 200. And then my x scale, okay, I don't want to count by ones and have 210 marks in there, so I'm going to count by 10. Now, my y min, I went down to like negative 5, and then I went up to about 70 feet. I just kind of guesstimated how high would a ball go. Again, I'm counting by tens. Leave your x resolution at 1, okay? So I adjusted my window, and I hit graph again, and boom, there's my graph. It showed up right there. Okay, so now what we're going to do is we're going to calculate the height of this thing. So if you got the blue keys right above here, you're going to hit your second key, and then you're going to hit calc. Okay? So make sure you hit that second key first, all right? And what's going to happen? It's going to give you this screen right here. You're going to calculate. Now, we want the maximum point. There's a bunch of things we can calculate in here. Mostly, we're going to use these four things: the zero, the minimum, the maximum, and the intersect, okay? So we're going to calculate the maximum. So just go ahead and hit 4, all right? And it'll bring up a screen that looks kind of like this. It puts this little cursor, like right here in this case, okay? And it will ask you left bound the maximum. So here's what you want to do. You want to use your arrow keys right here, okay? And you want to move this cursor so it's to the left of the maximum point. Make sure it's obviously to the left, but get it kind of close to the maximum. Then hit enter, okay? Now you're going to use the arrow keys to move it to the right of the maximum. And it's going to ask you right bound, and you're going to hit enter again. Okay, now look what it did here. Put these two little arrows up here, and what it's going to do is it's going to find the highest point between those 2 points, okay? And it'll say down here, guess, and just hit enter a third time, okay? And it gives me this screen right here. It puts a little X right there on the maximum, and it says the maximum is at 92.25893, and Y equals 54.665575. Now, I can round those, okay? 92.26 and 54.67. Now, what do those numbers mean? Well, the X coordinate, this, tells me how far the ball went before it hit its maximum point. So it traveled 92.26 feet, and then the ball had a height of 54.67 feet up, okay? Remember, the Y coordinate is the height. So I was able to use technology to find a very difficult problem that would have been difficult to do by hand. Okay, so now how do I find how far the ball went? Well, pretty much I do exactly the same process. I go back, I calculate again, only this time, instead of calculate the maximum, I'm going to calculate the zero. So I'm going to push 2. Okay? And then I'm going to go through the whole left-bound, right-bound process again. So I move the cursor. The cursor will probably show up somewhere around here this time. I'm going to move it down here because the ball's going to hit the ground right about here. Okay, so I'm going to make sure I'm to the left of that. Okay, I'm going to hit enter. It's going to ask me to right-bound it, and I'm actually going to go off the screen here a little bit. Okay, I'm going to hit enter again. It's going to ask me to guess, and I'm going to hit enter a third time. And it gives me this answer right here, okay? The distance the ball travels, 191.06 feet. And I know that it hit the ground at this point because Y is 0. Okay? So there we go. So we got a little assignment here for you to do. I look forward to seeing you guys in class, and I will talk with you later.